program has shifted to a hybrid program, which when you're talking about fabrication,
all right, guys, why don't we go ahead and get started? Thanks everybody for coming, especially at the studio. Appreciate that. So about 6 weeks ago or so, I said to Deborah, we don't really have a formal program for the faculty to talk about the work that they're doing and exchange ideas with one another. When somebody writes a book or does a project, we don't have a platform for them to just come and talk. Deborah said, that's a really great idea. Why don't you set that up and you can go first? So here I am. So I'm gonna walk you through this book that I finished probably 6 months too early, because I started writing this about 18 months ago when Reba reached out to me and asked me if I would write on this particular intersection of my interests, which are about the implications of technology for how we practice architecture. There's a whole other avenue of investigation that goes on in this building and elsewhere about more aesthetic or design or compositional or image related issues. That's not my wheelhouse. I'm much more interested in kind of what we do as architects, and most of my work, both professionally and intellectually, has been exploring questions of how those two things intersect with one another. So this is going to be a discussion more existential in nature about what this new wave of technology really means. Now, so Reba asked me to write this book, and they alleged, although it was never confirmed, it was more of a rumor than a fact, that they had originally reached out to Neil Leach, who is the architect who does a lot of AI work on the other side of the Atlantic Ocean, and asked him to write a similar book, and he refused. He said, he's purported to have said, artificial intelligence is going to destroy the profession of architecture, and I don't want to write about it. I don't know if that's true or not. At some point I will see Neil and I'll ask him. But so, of course, wrote this thing during COVID. It came out in, what was it, May or June of last year, just right before all the generative transformer new stuff came out. So as usual, my timing was absolutely perfect. I think the arguments are still valid. The examples are a little out of date. But given the moment that we're having this conversation, I've updated some of the thinking, or elaborated on some of the thinking that we can talk about here. Now, I want to give you a little bit of a backstory, kind of how I got to this, because this artificial intelligence thing has actually been something that I've been aware of, if not thinking about, for almost 50 years, believe it or not. So when I was an undergraduate here at Yale, in the mid-1970s, I wanted to be a computer science major and an architecture major. So I took the intro for computer science course, and then I thought, as an architect, the next logical course for me to take was Introduction to Computer Graphics. So I went to Dunham Lab, which is where the computer science department was, and I bought this $75 textbook, which in 1976 is like $400 today, right? And it became apparent that we were going to spend the first 3 weeks of the semester drawing circles on that thing that you see on the left, which is called an oscilloscope, which is a thing that measures electrical signals. So we're going to pump electrical signals into an oscilloscope and draw circles and squares. This struck me as extremely boring. So I sold the textbook, and I found this guy, this young assistant professor named Roger Schenck, who turned out to be one of the grandfathers of natural language artificial intelligence. And I took 2 courses from Roger on a lark on what was back then called natural language programming, or natural language processing. And just to prove that I'm not making this up, these are 2 scans of the printouts from my final project from first semester of sophomore year. I had to write a piece of code in a computer language called Lisp on this machine. This machine on the right is called some of you people are so far away from this that it'll take me a minute to explain this. This is what was called a mini computer back then. Mini computer meant any computer that was smaller than a small building. And and that's what we were working on. That's a computer called a DEC PDP-1145. It had a whopping 256 kilobytes of memory, and it ran at 3.4 megahertz per second processing speed, which means your iPhone is like 10,000 times more powerful. And one day when we were sitting in Dunham Lab working on this thing, it literally exploded into flames. It blew up into flames because there were like 12 of us working on it at the same time. So this is my Lisp program that answered questions about oil spills. I had to write a bunch of code, and then there used to be this thing called the AP Newswire. Remember that, Peter? That's how people used to get their news on like teletypes. And the thing would type out news articles. And my program had to read the news articles from the Newswire and answer questions about oil spills. So you can see right here, I'm typing in the first sentence from the oil spill. A Liberian oil tanker carrying a load of oil and rocks ran aground off Nantucket Shoal, about 27 miles southeast, blah, blah, blah. And then my piece of software had to do inferential reasoning about this oil spill. And Roger had a whole theory. Roger was kind of a religious figure. He thought that he had discovered the deep semantic structures of the human mind, and we could just write computer code that would allow you to interpret anything. I got an A- on this project because the TA said that my script worked equally well for an oil tanker crash and a car accident. Couldn't tell the difference. My code was indistinct. Things running into one another and making a mess. So, but I think actually what we're going to talk about today is actually a slightly more existential question, because what's happened in the history of artificial intelligence is there have been theories that run up against either the intellectual infrastructure of the discipline or the computational infrastructure of the discipline, and then it drops off the screen. So by 1980 or 81, when I was here in graduate school, we were in the middle of what was called the first AI winter, where everybody just gave up. It just wasn't working. All the theories of essentially hard coding intelligence weren't working. Now we fast forward to the early part of the 21st century, we're actually in a kind of different situation that I think asks some very interesting questions about what it means to be a practicing architect. And one of the most interesting books that I read on this topic was by these two guys from Oxford, the Suskins, father-son team. They wrote this interesting book called The Future of the Professions, How Technology Will Transform the Work of Human Experts. And what the Suskins essentially argue is there is this concept that we've been talking about in Sam's and my AI class called the Grand Bargain. And the Grand Bargain says, we are going to create this class of empowered professional people who are going to have great power and trust and have special education and be certified and make lots of money and have autonomy and be self-determined and have respect and status. And these people are called professionals, like architects and lawyers and accountants and dentists and doctors. And what essentially the Suskins argued was that the grand bargain is in jeopardy because the advent of machine intelligence creates a circumstance where the access to information and the ability to reason about information and the ability to extract results from information structures is going to become automated through artificial intelligence. And as a consequence, what the Suskins said in their book essentially is, we argue there will be two parallel sets of changes. The first will be dominated by automation. Traditional ways of working will be streamlined and optimized through the application of technology. The second will be dominated by innovation. Increasingly capable systems will transform the work of professionals, giving birth to new ways of sharing practical expertise. In the long run, this second future will prevail and our professions will be dismantled incrementally. Now, this is a hell of a paragraph to read if you are a teacher in this institution or someone who's decided he wanted to be an architect when he was 10 years old. It's like, shit, really? And then you start unpacking their argument. Their argument is kind of interesting. But I think their argument is very technologically deterministic in the sense that the Suskins argue that the uncontrollable autonomy of these algorithms is going to call into question professional autonomy. And the question that we're going to be talking about today is that really true? Is it really true that things that we do as architects can be replaced by machines? And I'm going to stipulate for the purposes of the rest of this conversation that the aesthetic questions, the compositional questions, the design questions are in somebody else's remit. I only want to interrogate this question from the perspective of how we operate as architects in the larger context of the economy, of delivery systems, of risk and reward and business models and all that boring stuff that most of the students learn only are subjected to in either Susanna's classroom or my classroom. So my book has a very simple organization. It looks at 3 classes of questions. Process questions about how we work, relationship questions about how we relate to the systems of delivery, and then the last section is my thesis, which is about results and output. And really, almost all of my work, the things that I'm really interested in, operate at the intersection of 4 sort of big topics. One is technology, like how does technology as an instrument change the way we work as architects? The second is a question of agency. What power do we have in these systems to move around, to do things, to make design actually happen? And the third question is delivery. We do not work as autonomous agents in the systems that create the built environment. We operate in relationship to a bunch of other players, and we're subject to a bunch of other forces. And then the last question that I'm interested in, which we've talked about at length in our class this semester, and is something that bothers me a lot, is this question of value conversion, which is, why is it that architects don't convert their value as professionals in the systems of delivery? So if you've read some of my other stuff, like my Perspective article from a couple of years ago, you'll know that I essentially argue that we're as well educated, we're much rarer, we work harder, we make things that people touch every single day, but we just don't get paid as well as everybody else. I want to know why that is the case. I want to know why that is happening, and what role might this set of questions play in sort of figuring that out. So I'm just going to kind of do a speed tour through some of the thinking in each one of these sections, and then we can talk about it. So the first thing you really have to do is set some kind of technological context for where artificial intelligence has come from in the evolution of the way we use technologies as practitioners. And one of my either skills or failings is I like to reduce things into really simple, clear, easy ideas that I can understand. And so this is the construct that I've been sort of using. So in my view, there are 5 distinct eras of instrumentation in our profession as architects. 3,000 years of putting things on drawings. And drawing is a very powerful thing. Drawings are cheap. Architectural language is extremely efficient. It represents a really big, complicated thing in a very simple way. A plan, a section, or an elevation transmits a lot of information. And we did that for about 3,000 years. Then what we did was we took all those processes and we put them on a computer. So we're doing exactly the same thing during the era of CAD, which really, at least in my view, started around 1985, when computers were cheap enough and there was cheap enough software available that we as architects could access that software. Then you have the first real serious representational break sometime around 2008, when building information modeling begins to see widespread adoption in the profession. And that was a representational break because we flipped the paradigm, right? What we were doing prior to that was abstracting things and using tools to make abstractions. Models now are 3-dimensional, behaviorally provocative representations of buildings, and the drawings are a report from the model. So you've got all this data there. And then sometime in the next couple of years, we're going to enter into what I'm calling the data interstice. And the data interstice is caused by the intensive, random, disorganized, non-coherent digitization of tons of processes in the building industry. So it was during my time at Autodesk, when we spent $133 million on Revit Technologies to buy that company, that was the single largest investment ever made in architecturally specific software in the history of mankind. Fair enough to say, Sam?
Accurate.
Accurate, right? Nobody had ever spent that much money on an architectural tool. Now it's everywhere. Last year, the building technology industry had $5 billion in investment. There's startups everywhere. Everything's getting digitized. It's totally random. There's no rhyme or reason. People are doing all kinds of crazy stuff. And my thesis in this book is it will require some kind of meta process, likely driven by artificial intelligence, to rationalize all of that data and get to the next era of coherence. So we'll talk about what that means in a little bit more detail. And so the other thing that I was interested in was looking at the intersection of what I believe to be the taxonomy of different types of technology that we deal with as architects. And so if this axis here are the different kinds of tools that we're using, this axis represents a series of categories of the way we use technologies. And I tried to convince my colleagues at Autodesk years ago to use this taxonomy, and they were deeply disinterested in it, but I still use it today. And what I argue is, right now we're using technology for four things: to represent the designs that we're trying to generate, to simulate and predict their behavior, to translate them into physical reality, and to move the data and connect ourselves with data and with our collaborators. And pretty much every tool that you've seen for the last 20 years fits somewhat neatly into this taxonomy. And the taxonomy is useful because it gives you a trajectory for how you might see the arc of these technical capabilities evolving over the course of time. Because humans have been using abstractive strategies to represent buildings. That's a floor plan from 3000 BC in that sculpture in that little statuette of Medea. And then that's an early AutoCAD drawing from the National Airport project that I worked on in 1992 when we were just first starting to exploit the idea that we could draw big things more precisely with computers. This kind of two-axis problem you'll see represented in a little bit more detail. But when you make the transition from, say, BIM or CAD types of technologies to technologies that are more capable, you need some kind of strategy for understanding what they're capable of doing. And so I looked at two ways of thinking about this. One was to categorize the technologies that we have available today in three sort of buckets, what I call algorithmic software, empiricist software, and cognitive software. So algorithmic software is what's on all of your computers upstairs right now. Everything's completely hard-coded, right? Somebody sat down and wrote lines and lines of code. That copy of Revit on your machine upstairs has, what would you say, Sam, 6.5 million lines of C++?
I wouldn't even know.
It's just a huge bowl of spaghetti, hot mess. I can say that now, right? Anyway. But it's algorithmic, right? It's all hard-coded. There's very little ambiguity, and the machine has zero autonomy. Then when we break into these artificial intelligence constructs, I think they fall into two categories. What I'm going to call the empiricist systems that just go out and engorge themselves with tons of data and try to understand the world through correlation. That's what essentially a machine learning network does. And then the other more interesting idea, or more provocative idea, goes back to my LIST program from 1976 in Roger Schenck, which is what I would call cognitive or common sense learning systems. Systems that can reason about the world, make inferences about the world, and as you'll see a little bit later in this argument, make counterintuitive arguments about the world. In other words, reason about what's not going to happen. Right now, these empiricist systems are alleged, these deep learning systems are alleged to quote unquote understand things because they have billions and billions of statistical correlations. But as we've seen from lots and lots of examples, they don't really understand it. They don't understand in the traditional sense anything because they can't reason counterintuitively. And one argument suggests that we're only going to get to real artificial intelligence, or what's called artificial general intelligence, where a machine can understand its context and reason in context, when there's some kind of cognitive structure there about how the world works, right? So when I drop this book on the floor, all of you know that that book's going to drop on the floor because you understand the rules of gravity and you've seen it happen a million times. You cannot interrogate a machine learning system about the rules of gravity. It understands a lot of correlated language about the rules of gravity, but there's a 30% chance that when you ask it, what happens when I drop a book, it'll say it's going to fly up into the ceiling. It has no cognitive infrastructure. And the reason this is important is that distinction is hugely important for what we're going to be able to do as architects. We have to be able, somebody has to assert that set of ideas. And so I wanted to try to create a construct that builds a hierarchy of capabilities for these technologies in order to evaluate how they might work relative to what we do as architects. And so I started with Bloom's taxonomy, which is the kind of thing every teacher learns, the hierarchy of things that you use as strategies for teaching. Like, all I want you to do is remember this. I want you to be able to classify it or understand it. Then I want you to apply the knowledge. Then I want you to be able to analyze it, evaluate it, create it, and so forth. This very classic taxonomy of learning. But my friend Mark Graves, who's an artificial intelligence computer scientist, has a different structure that I thought was really interesting. It's his version of Bloom's taxonomy applied to artificial intelligence, which is things have to understand the context they're operating in. They have to be able to evaluate that context. Then they have to be projective. They have to be able to project into the future what's happening. And then from that set of abilities comes the ability to create, right? And so you can draw your own conclusions about the extent to which the current sets of technologies are capable of doing that, but there's definitely a relationship between Bloom's taxonomy and the capabilities of these algorithms. And so what I tried to suggest, and I'm not going to go through this in detail, is if you take that taxonomy of understanding through creation, and you look at and you create an intersection with the evolution of the technologies from drafting to machine learning to generalized artificial intelligence, you start really low on the hierarchy with basic documentation, and you get to Nirvana, which is a magical computer completely designing a building with no human intervention. And there has to be a series of steps sort of in between. And so what I argue in the book is that there is a route to seeing this happening, but it's a long, long route that starts with, manual documentation, then getting to precise geometry in CAD, moving across precise geometry into the world of BIM, where you can start doing modeling and analysis. And then when you cross into machine learning, you can script or guide generation by training these algorithms, but you're only going to get so far. And we have to cross that next boundary of artificial general intelligence before we get to the full, unguided generation of ideas that architects do every single day. So I think that's good news. That's the good news in my view. Until we get far to the upper right-hand corner of this diagram, I think the existential threat is, to some degree, at bay. However, there are significant challenges, both from a technological point of view and from a business point of view. So one of the things you need to have to train these algorithms is lots of information. You need lots of data. And the information on the internet that the large language models are trained under is all billions and billions of sentences. So there's a large enough sample size there that you can create some pretty incredible correlations. I could take every single building information model on the planet that exists right now, and it's not enough data to train an AI. We do not have enough data, which means as a profession, we need some kind of knowledge strategy. So I looked at this knowledge question from a bunch of different ways. One of the things I did was, because this is a REBA publication, a British publication, I looked at our curriculum here at Yale versus the curriculum required by the Architectural Registration Board in Britain versus NCARB, which is our licensing authority, to see where the different emphasis was based on the test regimen and the curriculum. And it was really the point to say, we do not have a theory of knowledge in architecture. Anthony, I would love to hear your thinking about this at some point from your perspective as a historian of science, because there's not much data. But what we do have is a ton of technologies spitting out data. No theory of knowledge about how to organize it, but tons of things generating it. And you know, when I wrote my last book, which was about these same set of questions, but really more focused on building information modeling and technology around 2018, you know, the original thesis was that these modeling technologies were going to create this data nirvana, self-reinforcing. I mean, if I had $1 for every time I showed one of these slides with a circular data diagram on it, I'd be retired, right? Like, the BIM is going to create great data that's going to help the contractor, and then the data the contractor creates goes into building operations, and then that all feeds back to the designer so she can make an even better building next time. And this is all bullshit, right? And none of it worked. None of this worked. This was a thesis that transmogrified into a marketing campaign. It did not actually become anything real for reasons that I'm about to argue. And so the question is, with all of this disorganized data flowing around, is there a strategy for seeing a world where this knowledge is better organized and can be better understood, and we go from algorithmic data generation to the ability to act in some way autonomously? So the thesis I put forward in this chapter was that there are two things that have to happen. The stuff in the green box is all the stuff that we create with our tools today. Models and drawings and scans and structural analysis, construction management data, building control system data that turns on your heater and forces your air around. And we have to find, from a strategic point of view, we have to do two things to all that data to make sense out of it. One is find some place to put it coherently, which is called a common data environment. And the other is apply some kind of intelligent templates that can process it into accessible data that can be used to train these algorithms. And if we will never go from the green box to the pink box by ourselves. There's going to have to be some kind of intermediating force. And when we get to that intermediating force, and if we control it, meaning we control our own destiny as professionals, then we will get to certain tasks in the design process being automated. Like if I never had to detail another fire stair in my life, I'd be super happy. If I never had to check where a 2-hour wall was ever again, I'd be super happy. Sam and I were having lunch today on the 7th floor terrace. There's this really ugly chicken wire around part of the Rudolph building because Rudolph did not think about pigeons roosting on the roof. This is really kind of prosaic stuff, but you can take the extra time that algorithm gives you and spend it doing something else, like going to the movies or working on your design. Those are your two choices, right? Take some time off, work harder on your design. And there's a whole series of those kind of pink box questions. But at opposite ends of the design continuum, there are interesting things starting to happen that could create this kind of information. At least I think they're super interesting. This thing right here is a tool called Upcodes, which takes a building information model and does a code analysis of it. So it checks your stairs, checks your exiting, makes sure your doors are swinging in the right place, does all that sort of super boring stuff that nobody wants to do. But there is, of course, a problem with that, and we'll discuss it later. The image on the right is the 6 PhDs it took and the lengthy paper that I read on making a robot that can paint a sheetrock wall. So that's a robot called Pictobot. And I read a like 40-page long paper where these guys designed and programmed this robot to paint a sheetrock wall. So there's a kind of disparate effort to effect ratio there about the magical circular relationship with the data, kind of broken, right? Doesn't really work very well. So the second big question in this process issue is, where are the places in the architectural process that are most likely to be rapidly automated by semi-autonomous algorithms? And I won't bore you with the details here, but what I tried to do was look at the structure of scopes of service in the US and in the UK, which is up here. These are the phases of work that should look familiar to some of you, I hope. And then I looked at different consistent components of those tasks. And then I looked at the degree to which those tasks vary from things that you could write steps for, like I could explain to a young architect, do this, do that, do this, do that, do this, and then you're done. Go find all the doors in the building. Give them all a number. Make sure you understand what their hardware is. Pick out a paint color. Make sure they have a frame. It's all procedural. To the other end of this continuum that I call perceptive, which is you have to actually understand and interpret something, like understanding the program or generating design alternatives. And what you see, the way to look at this diagram is all the red stuff and the orange stripy stuff is likely going to be automated. And what I'd like you to remember as we talk about this is this section right here, which is between sort of at the edge of concept design until you get to the end of bidding. Because this zone here, which is, in my view, heavily likely to become automated, creates some really, I think, interesting challenges for us. I spent some time looking at what sorts of potential algorithms might be the early opportunities. One way to look at this is a list of potential startups. If you want to do a build tech startup, you can look at this list and see various tasks that I think are likely to be subject to automation. And this is kind of not super sexy stuff, right? Cost estimating, spatial coordination, trying to understand how much construction is actually in place. When you walk around on a job site as an architect and you declare that the structure is 30% complete, you mostly made that up by eyeballing that thing. But your structural subcontractor cannot feed his or her children unless you get that number right. So there's a whole lot of just interstitial, liminal, technical science that I say we delegate to these algorithms. Let these algorithms do that sort of stuff for us. Like, look at my operating model, my practice, and identify where I might be having a problem. Hey, it looks like your overhead multiplier is too high. You're paying people too little in this area. Your insurance premium is too high. Just like super boring stuff. So we can do the stuff that we really like to do, which is design stuff. And so but I feel that, and what I argue in this thing is that we need to make, we need a strategy around that. And so at the end of this chapter, I wanted to look at project delivery models, because that's, those of you who know my work know I'm kind of obsessed with this stuff. How do all the players work together? What's the relationship between the architect and the contractor? What is the contractor really doing as opposed to what you think the contractor is doing? But I tried to look at that in this context through the lens of what architects actually do. And I made an argument that we play 4 roles as architects in the world. We protect the public's health and safety, because that's our job as licensed professionals. We act as an agent and an expert to the client to help them design a building. We act as a guide to the contractor, like, this is what I had in mind when I drew this. Please don't F it up, right? That's what happens during construction. And then we run teams, we run consulting teams. And each of these roles has potential augmentation. And what I argue is augmentation meaning things that machine learning algorithms could assist in. Like, for example, helping the contractor understand the underlying procedures that the thing that I have designed imply, like construction sequencing, for example. The danger, of course, the risk is these things taken too far, uncontrolled, could essentially eliminate our role. And where I think there's a significant existential threat is in this lower right-hand corner here. Because the reason that licensed architects exist in society, there are highfalutin reasons and there are lowfalutin reasons, right? The highfalutin reasons are the ones we spend time in this building working on, about the importance of making an appropriate built environment. From society's point of view, however, you have a license to practice architecture to protect the public's health and safety. That's your job. Protect the public's health and safety. Once that gets automated away, and codes on steroids replaces both your code checking and the building official, we have a really interesting situation where there's no longer a reason to license architects unless we decide we're going to redefine what the public's health and safety is in some other frame, like social equity or climate change or a number of other kinds of issues around what the real safety of the public has to do. That's a different book. That's really kind of a different book. And so if you look at the evolution of project delivery models carefully, what you can see is architects have gone from the diagram on the top, which is the way architects worked in the United States and in the UK in the 18th century, where you notice my students notice there's no contractor in that diagram? We were the contractor. There was no such thing as general contractors. When we decided we didn't want to do that stuff anymore, we invented the profession of general contractors because we didn't want to be messing with those mechanics, right? And so the project delivery models have evolved to be far more complex. And what Paulo Tombesi, the labor economist, argues is these structures actually don't properly define what architectural practice should be anymore. That we should be more concerned with what he calls the concept of flexible specialization around the objective of building design. And that design is a problem that has multiple dimensions and requires technical integration. And those are things that we as architects are really good at. I argue that we could augment those capabilities of all these little lily pads on the pond here, all these different things that Paulo argues that we should be doing around defining the building, deciding how the building is going to be made, operating the building. If we could augment our services, augment our ability as architects with the opportunity of these new autonomous technologies. Am I making sense to you guys so far? Yeah. So one of the places where I've gotten super interested in this question is in this other work that I'm doing right now on modern slavery and the supply chain. And this is a diagram we used with our students last semester to explain I'll explain quickly how that sketch by Charles Gwathmey, which is the one in the upper left, and his decision to enclose Loria Hall in zinc enslaved that Peruvian child on the right. All the different steps and all the different people who made decisions that ultimately had that result. And this becomes a question of understanding the relationship between different kinds of information and reasoning about that information, and we as humans are not good at that. And this could have been a slide about the Grenfell fire, it could be a slide about embodied carbon, my interest happens to be in this, but it's all about building information structures and tools that we can use to reason about those information structures. So in the next section, I talk about relationships, and this is really about how technology affects the efficacy of architects and what has happened in the past and what might be expected to happen in the future. So I kind of made two observations. And the one on the top, I looked at the productivity of the American architecture profession between 2005 and 2013. And in that time period, two things happened. One, we had a terrible financial crisis that took the net revenue of the profession way down below $27.5 billion. And then we had a recovery. Two, the adoption of building information technology tools went from small to significant. And what ended up happening in that period was the number of firms using BIM tripled. The amount of revenue they earned from 2005 to 2013 essentially leveled off as a proxy of their productivity. But the number of architects that it took to do that work shrank by about 15%. Now, and Peter, I'd love to hear if that's consistent with your experience. But what we were hearing when I was at Autodesk, what we were hearing from a lot of firms was their productivity went way up with these tools. They weren't making more fee, they weren't more profitable, but they were a lot more productive. Susanna, Axel, you guys agree? I mean, Kermit Baker, who's the AI economist, and I are arguing over how you measure architectural productivity, but right now, as far as I'm concerned, revenue is a proxy. So then I did this super interesting graph, I thought, which was, this is the number of employees in architectural practices, which are the net revenue of architectural practices relative to their profitability and their BIM adoption. And so what you see here is, after about 2008, the slopes of these curves are roughly similar, right? The revenue begins to increase, profitability begins to increase, and technology implementation increases. But what that means, though, when you look at what we actually did in the world, was we used these tools to optimize internal productivity. We did not use these tools to do anything else. We didn't use them to give better information to contractors. We didn't use them to drive prefabrication. Barely anybody was doing sustainability analysis. There were all these opportunities in the data. None of them got used. All the tools were focused on making the internal operation of architecture firms more efficient. And what I argue in the book is that's potentially a huge mistake. That is potentially an existential error. Because what these technologies should be able to do is progressively get more capable of doing not very interesting things. So the example I cite is, let's figure out how to evaluate the code of a building, right? So first thing we can do is use the technology to find all the doors and the stairs in the building. Then we can check the dimensions to make sure that they are close to right. Then we can put those stairs and doors in the building and test it under fire conditions, which is essentially an analysis simulation. Based on that data, we can say, this building is safe, it's unsafe. And then, based on the information that comes from that, we can use that insight to generate compliant schemes with alternatives. So the technology's capability goes from the upper left-hand corner to the right-hand corner. And if we can control these processes, that's a value proposition for architects, right? That's a way of using our capabilities, training these algorithms to allow them to do what I think are kind of super interesting things. And so what I essentially suggest that is risk becomes the common denominator that allows us to make decisions about how what the technology strategies should be for these types of software. That if you look at this agent, leader, guide, protector construct, and you look at the potential failures that might occur there where we take the greatest risk, rather than optimize around productivity, we should be correlating the development of these tools around reducing our risk. And things like carbon and code and technical conformance and technical performance, which are things that we would honestly, at the end of the day, rather not be spending our time doing, are precisely the things that these algorithms should be doing in a different kind of optimization. And finally, I think a strategy like that creates an environment where we have some protection from the potential of being replaced by these things. And so I read a lot of work by this guy, Judah Pearl. And Judah Pearl was the guy who invented the underlying theory that eventually was extrapolated into machine learning today. He's the one that invented the theory of Bayesian networks, for those of you who follow this stuff. But he argues in this book called The Book of Why, that these technologies will never be useful in complex contexts because they can't reason counterfactually. He has this, what he calls the ladder of causation, where you have to be able to associate information, intervene to ask the right questions, and then reason with counterfactuals. And a counterfactual is, why didn't this happen? So in our case, for architects, it's, why didn't this fall down? Why didn't this hurt someone? Why didn't this leak? Why? You see what I'm getting at here? It's a different subtle kind of reasoning. And Pearl argues that these artificial intelligence algorithms in the machine learning context will never get to be able to be counterfactual. I actually think that's an opportunity. So here's a recent example, just for fun. You should go watch this YouTube video called "We Tried to Compete with an AI versus Architect," where these guys gave several AI algorithms textual prompts to design a house. And they raced against a human team of 3 young designers. And then they, of course, because it's the era of social media, they had a vote online. And everybody voted for the AI scheme. Right? Nobody this was what they could come up with. Like, humans came up with this scheme in a couple of hours and had a rendering of an actual building. The AI came up with this thing that looked like a plan, but if you look at it, it's not an actual floor plan. It's completely nonsense. And then drew an image of a building that had nothing to do with the plan. So there is no correlation between any of this stuff. This algorithm understands images and words, and I use understands in air quotes. It can't actually do architecture. So I thought, okay, let's give it a simpler problem. This was a prompt from last night. Give me the plan of a fire stair that allows 100 people on the 4th floor of a hotel to exit safely to the street during a fire. That is a pretty straightforward thing. Rise, run, dimensions, railings. Pretty simple thing. Anybody in this room can do that by reading the code for 3 minutes. What you got was this. Whatever that, I don't know what language that is, but Liebig T par di Asian Safto pod de pat. I mean, it's garbage, right? These algorithms are nowhere near ready to do synthetic thinking. They're provocative. They create really super interesting images. Now, but before everybody breathes a giant sigh of relief, go read this. If you don't follow this guy, he's really great. His name is Brian Potter. He writes this Substack called Construction Physics. He writes on all kinds of really interesting stuff. But last week, he took ChatGPT and gave it the architectural registration exam. And what he found was, a significant amount of time, it was actually right. That's the good news. The bad news is, couldn't feed it any images, couldn't do anything that related to drawing. So it only took half the test. But when it took half the test, here's the pass rates. For the half of the test it could take, it was above or within passing range for all 6 sections of the ARE. Now, what does that tell you? Does it tell you that an artificial intelligence algorithm, in theory, can be a licensed architect? Or maybe the kind of plebeian, prosaic stuff that they want us to memorize to take this test is just as easily looked up online, and that maybe the test ought to be redefined in some different way that's more consistent with what we do in an interesting way as architects. I mean, I read this, and I read this more as a condemnation of the exam than I'm super worried that you guys are going to be supplanted by a ARE taking. And by the way, we don't have time to go through it, but when you read this Substack, he shows the results for the LSAT, all the AP tests, and this thing killed on all of those. He got 5s on like 11 APs. So something's amiss with the testing, right? The challenge, of course, is that the systems that we use to certify architectural knowledge and competence, which operate, as I argue, from the academy side in terms of accreditation and curricular structure, and on the profession side in terms of organizations like the AIA and certification organizations like the NCAR, are completely not up to this task. Completely not up to this task. It takes years and years and years to get any of this stuff to happen, anything to move. So this is not coming from the academy, and it's certainly not coming from the standards and the strategies for dealing with these questions are going to have to come from someplace else. So the question in the next section of the book was, what's actually the strategy for that, right? And so the argument that I make is, we as a profession should define a set of problems that we think are the most helpful and define them clearly enough that the technologies can move in that direction. And I created a kind of list of things that I thought would be most impactful, and the greatest sort of effort to effect ratio, whether it's zoning or code, kind of coordinating spaces, calculating carbon. Cost is a huge issue that we were really terrible at. Monitoring, managing, predicting, analyzing construction costs. Not sexy, but things that might happen. And you're starting to see the very beginnings of the emergence of these technologies that can begin to understand, evaluate, and simulate conditions on the ground as the design is evolving. This is some of David Benjamin's work, where he uses artificial intelligence and machine learning algorithms, and he takes a scheme that he's working on and he hyper-optimizes it for one variable. Like, make this scheme have the most daylight. Now make this scheme pack the most people in. Now make this scheme cost the least amount of money. Then he takes all of those answers and then combines them into the actual solution that gets built. The machine does not build the solutions, right? So I think this is the right strategy. I think a combination of this idea and this idea is the right strategy for these technologies. And the only way that's going to happen is, what I argue here is, in order for this to happen, we need a place to park a whole bunch of data, and that there's no place in the world right now to park all that information. There's just no place to do it. We need an industry-wide data trust where information can be properly curated, anonymized, and protected from risk, where everybody can pile their stuff. I call it an industry data trust. And then we can use that data trust to train these algorithms. Because otherwise, I mean, we can't even get the architects and the contractors at the same table to agree on what to order for dinner, much less collaborate at the level that I think this is going to be necessary. And so if we can get that kind of data infrastructure, that kind of fat middle of the automatable tasks, which I think are largely around the information analysis of construction and cost estimating, is really the sweet spot. What you're seeing there on the right is Foster's office using a robot from Boston Dynamics to do construction inspection. And on the left is a company that uses machine learning to do scans of construction sites and evaluate percentage of completion of construction systems. So it takes the building information model, guy walks around with a camera on his head. He used to have a much cooler robot, but they gave up their robot. Couldn't get the robot to work. So they put a camera on a construction worker's head. He or she walks through the building, comes back out, tells you that building systems are this much complete. This is how much the contractor should get paid. Anybody want to do this for a living? Because 20% of your fee is doing this, right? In fact, I think the danger here, the real danger here is the following. This is the chart on below shows where the curves of the number of architects in the UK cross the amount of work they were doing. Green is the number of architects. Blue is the construction value of what they're designing. The number of architects is declining. The construction value is increasing. So if you look at a comparison of the scopes of all these places like the US and the UK, I lined up a scope of service diagram for each one. From schematic design to construction administration is what's called basic services in this country. That's what architects get paid to do their basic work. From somewhere, design development, construction documents, and procurement are 60% of the fee. That's the fat middle of the part of the process that's likely to be automated. So let's just say arbitrarily, it's half of the 60%. By logical extrapolation, we now need 30% fewer architects in the world than we did before these algorithms existed. That's 30% fewer jobs. That's one empty floor upstairs. And it's a reduction of, there are about 1 million architects in the world right now. It'll take a while for this to happen, but all other things being equal, there's not enough money to support 100% of the architects that exist today. If this Suskinian thing happens. And so the question in my mind is, how do we avoid it happening? How do we actually get away from being commoditized out of existence? And one of the constructs that's useful to think about that is this thing called the Mclaney Curve. It was written by Patrick Mclaney when he was the president of HOK. And basically what he says is, the earlier you are in a design process, the easier it is to control cost. The later you are in the design process, the less easy it is to control cost. The more likely it is a change is going to make an implication. And this curve right here represents all the calories you spend as an architect working on a project, distributed by traditional AI phases. But all the value is up front, right? That's all the key decision making happens up front. So why not delegate all the routine stuff
to algorithms and do what we think is really valuable. Whoops, that's my daughter. And do what we think is really valuable, which is the upfront stuff. Delegate the back-end stuff to the evolution of these algorithms. The problem is, if you do that, you need a new business model for that to work. Because otherwise, the clients are simply going to cut the fees off at 20%. So we can use, there's been all sorts of experimentation in new kinds of business models, including in my Exploring New Values class, which is on the left, Shop operating as a contractor on the upper right, Karen Timberlake building software, lots of experimentation about new business models. But what we need to be able to do, at least in my view, is convert value. We have to use these technologies to make things happen instead of getting paid for time. And if they actually do enter into this realm of simulation and creation, then we can use them as projective tools and say, here's this beautiful building I designed for you, and it's going to cost X, and I promise. It's going to use Y energy, and I promise. It's going to reduce the amount of embodied suffering because we're going to use a supply chain that doesn't involve enslaved labor. And I promise, if these things happen, I want you to pay me. That's a whole different lecture. But the value proposition conversion is predicated on this idea. So essentially what I do is conclude that the profession needs to do 5 things. We need to define the technologies that we think are going to be most useful. Otherwise, I can tell you, there's a vendor and an ex-vendor in the room right now. He's the vendor and I'm the ex-vendor. The technology companies will chase whatever's most profitable. They're only marginally interested in what we want as architects. And we are a small piece of the system. So if we're super clear to the technology vendors and we save them all the work of figuring it out and making a lot of mistakes, they will go in the direction that we point them, right? We need to change ideas of design value to performance because we're never going to get paid to design beautiful things. I'm just going to tell you that bluntly. That's how the world works. Clients want that, but they don't pay for it. It's just a fact, a hard fact, right? We need the data infrastructure that I discussed. We need to refactor the relationship between design and construction and operation. And thereby, by doing all of these things, we can actually shift the value proposition of design. And I think, just to conclude, this is both an issue of expertise and an issue of ethics. I think these technologies right now are largely running amok. In order to control them, we're going to need experts. We are experts, and there's a lot of discussion going on around the ethical implications of these systems, and we as a profession should create those ethical guidelines, at least in my view. So this is kind of speed tour through relatively short book. Okay, Sam.
Okay, so my role, I'm told, is as respondent. So I will respond. And in thinking about how to respond, I decided I'm going to do it in 3 frames. And those 3 frames are the frame of being the audience for the book, like everyone else in this room. The frame of being a historian, and the frame of being a technologist / former practitioner colleague. And so, starting from the frame of the audience, I'll point out, because Phil would be too modest, the book has made actually a really big impact in the conversation among people who are interested in architectural technology. And I did a non-scientific survey where I queried the Topline reactions of some friends and colleagues who have read the book. So this is what I came back with.
Oh wait, wrote it too soon, colors too lurid. Right?
Wrong. Printing looks great. Revisit printing. No, actually, let me start with my own, actually, in front of this list. When Phil, when you opened your talk, you said that, you pointed out in writing this approximately 1.5 years, 2 years ago, that you thought some of the arguments stood, that you thought some of the examples were outdated by the huge influx, the cyclone of popular interest in machine learning and computer intelligence. But I'd add one more thing that I think really is the main contribution of the book, as far as I'm concerned as a reader, which is the frameworks you offer. And those frameworks, I think, you know, will stand the test of time as the technology changes. And in fact, one of the people that I queried said that the frameworks offer a way of thinking through this technology at a different pace. At a different pace than the New York Times, at a different pace than Ezra Klein. Someone else said, I thought it was strikingly prescient. There were no indications in the architectural discipline, at least, that last year would be the year before this cyclone of popular journalism and breakthroughs with open source APIs would stimulate an imagination of the wider public, an interest in machine learning renewed. And then the third, which actually came out of a conversation I had with somebody more interactively, was that they pointed out that the book avoids an overly romantic view of technology, which I think is incredibly useful and incredibly sober, especially when speaking about the ways in which technology is going to have a role in defining the future. It's easy to let questions fall between the cracks, and I think you're grounded so effectively in thinking about, what does this mean in terms of project delivery responsibilities? What does this mean in terms of architectural culture? What does this mean in terms of social ramifications? Pointing out aesthetics as well, not being focal, but it's there as well. So to summarize the sort of top-line reactions of our professional peers, the book is incredibly useful, incredibly prescient, and everyone had something to say about that. So the second kind of frame that I'll pivot on relates to threat, which is something you brought up in the talk, and I think something that is really at the center of the book, this question of the threat of technology to the profession. There's probably people in this room that are not very interested today in technology, not very interested today in professional practice. So this is for you. I'd like to frame up what I read Phil is saying in a sort of wider historical discussion from the history of architecture that most of us may be able to relate to a little differently than what I'll go to next. And this is this question, I think, that's haunted architecture for quite a long time. And that is the absence of an explicit problem definition in the act of design. Stanford Anderson contrasted problem solving to problem worrying. And by problem solving, I mean, I think the most obvious example from sort of immediate and history, at least one good one, is the first quarter of the 20th century in the European German-speaking scene, and what you'll have heard called functionalism. And so Hannes Meyer, who was a Swiss architect and at that time the director of the Bauhaus in 1928, called architecture, he quote, a functional diagram of daily life. The functional diagram and the economic program are the determining principles of the building. So in other words, architecture was all about the problem of fit. And what I read into Phil's book when he's talking about the objectives of design is about this problem of fit, this relationship between defining a problem, executing on a performative solution to that problem as being fundamental to the architect's professional task. Now, to stick this in some tension with a different alternative framing of the architectural task, this notion of problem worrying was a problem. This is Stanford Anderson's anachronistic framing. There's nothing Myers wouldn't have thought of it, but at the Bauhaus, Myers was battling with a group of folks you might have heard called the Expressionists. Someone like Vasily Kandinsky, the Russian emigre painter, is a great example. But there were architects as well, and this approach to creativity, to decision making, if I could be so vulgar as to sort of paraphrase a large intellectual movement, was that the purposes of the design are incompletely known at the outset. They're incompletely known. You can't frame up a design problem in advance and then just solve it. because the nature of design is that what's known at the outset, it can't be extrapolated from the known purposes. So the conclusion is going to work recursively as it redefines the problem. And so bringing this back to the discussion tonight, there will be architects, there will be creative people that will look at the framing of the objectives of design in this book and the objectives of design that it turns machine learning to attention on and say, well, I don't know if that's what architecture is all about. We're not going to resolve this question in this room. That's not the intention. But I wanted to frame this in a particular intellectual, this conversation, a particular intellectual history from an architectural perspective. And it would seem to me that machine learning is not different fundamentally from some other information technologies in the past, but it makes the nature of the problem far more vivid because of, and the problems I'm about to sort of try to respond to here. But it makes the problem more vivid because of the speed and magnitude of the implications, the power of compute behind some of these processes, and the way that the processes themselves manifest in different forms of information systems and decision making. So that leads to the third frame. And I mean, these are actually my original notes from reading this book a long time ago. So one of the things that you call out explicitly, Phil, in the book, but which I think is super, super fundamental to the argument more widely, is this notion of trust, and this notion of what you call the need to create, consume, and curate data as part of an AEC project. And one of the interesting things about AI, of course, is that it really introduces a step change in agency for its users. I mean, if we think about a world where machine learning is deployed effectively, this does things like put the threat of labor potentially on the table. And I guess what I'm left asking is, have we finally reached a point, or are we in view of a point for technology where there is a significant step change whereby that lack of trust in AEC is going to be a moral flaw? In other words, architecture and AEC in general will fail in its own abilities as a profession, in its own abilities as an industry, simply because, for very banal and technical reasons, we cannot execute on the promise of machine learning because we can't trust ourselves enough and our peers enough to create a CDE, to create a place where, to create it's a great term you had, to create, what was the term that you used, Phil, for an industry place where we will put our data?
The industry data trust?
Thank you. To create an industry data trust. If we fail at this for mechanical reasons alone, we will not be able to operate with these tools which leverage historical data. And that's a fear, I think, of those of us speaking as a technologist who try to make tools today for architects to use tomorrow, that we won't be able to get our act together, as professionals. And so I guess where I'd like to end is on this question again, where you started with the grand bargain. Is part of our professional responsibility in the value chain to be the ones that stand up for trustworthiness, stand up for an environment that's not only about our own efficiency and our own risk mitigation, but about our colleagues' efficiency, our colleagues' risk mitigation, and the ability to together make a better built environment? Do we want to hold ourselves up as being the ones that kind of conquer the tragedy of the commons that today is the litigious environment between contractors, engineers, and architects? Be curious if you see the architect's role as being distinct in that effort.
Well, I think that proposition is interesting and extremely problematic on a bunch of different levels. I mean, in my days, kind of operating in this environment, I went to a lot of, these, let's get the players around the table and talk about solving the problems of the industry. And those meetings always had two characteristics. Number one, no matter who was at the table, the architect always figured out, okay, how are we gonna get ourselves organized? And what are we gonna talk about? What are we gonna produce? And half the time, if they decide to write a paper, I got assigned to write it, right? And the contractors wouldn't do it. The owners wouldn't do it. That was kind of characteristic number one. Characteristic number two, nothing ever happened. There was never any action about this. And I was actually reading a paper today to prepare for another presentation about the challenge of innovation in the building industry. This paper argued that there are three axes of innovation, none of which work in the building industry. What they call the horizontal axis, which is the architects don't want to help each other, right? The vertical axis, which is there's nobody whose job it is to figure out a standard that would connect the architect, the contractor, the subcontractor, the suppliers, right? And then what he called the longitudinal axis, which is even if a team gets together and comes up with a really good way of doing things, that's not the team that works on the next project. So the industry itself has this sort of sense of disaggregation. So I think there's a real question. I have no doubt that we could come up with a great design that addresses the problem. The issue is implementation. And the thing that worries me about where this may be going is the builders are highly motivated to work on this problem, right? I mean, the Autodesk construction business went to from zero to a 9-digit number in less than 4 years, right? It's a huge business now because the product strategy makes no sense whatsoever. I think I can say that, right? So they're doing this, they're doing that, they're making money here, they're doing this, they're doing that. There's no coherent. It doesn't cohere. But what the contractors are doing is generating a huge amount of big data. And if that data becomes the data that the algorithms are trained on, and then we are handed that data, they're going to have a very specific kind of bias that we are not going to like. We are not going to like. So I feel like we need to find some way of creating an approach where we can convince everybody it's in our collective interest to kind of pile all this stuff together. I don't know how that's going to work. I'm nervous about that. Does that make sense?
Yes, it does. Do you think about it as a technology problem, a people problem?
It's a sociological problem. It is not a technology problem. Graves told me that, he's been an AI scientist for 30 years. Says 50% of the work of training an algorithm is curating the data, because the data is always a huge mess, right? So, and it's going to be an even huger mess for us, because in this room right now, there are 33 different ways to draw a door. Right? In your heads, there are 33 different ways to draw a door. We don't have standards. We don't. We have vague standards like CAD standards and Revit families and templates, but we don't have standards. So even if we can collect the data, it has to be curated. So who's going to do that? The building industry is, 14% of worldwide GDP? There's a clear financial motivation to do it, but there's no place to go. There's no UN. There's just no place to go. So, there you go.
I had a question about sort of precedent for pooling data and information and sort of protecting it for a sort of wider use beyond a certain narrow private or business interest. And I'm thinking about the failure of things like, or the erosion of net neutrality, the sort of privatization of utilities and infrastructure, and do we have enough of an ethical precedent for pooling data and protecting it as a common good against sort of these efforts to privatize our
Yes, we do. The doctors do it all the time. The medical profession does this all the time. All of their medical diagnostic data, their pharmaceutical data is all beautifully curated, well organized, and easily accessible. Ditto for the legal profession. So I wrote an article recently where I needed some legal research, and my daughter's a lawyer, and I texted her, and 3 minutes later, she sent me a list of every single case in the history of mankind related to this topic I was writing about. And it was like, bang, just like that. We don't have anything analogous to that. And it's going to require some kind of will, political, economic will, to create that realm where the data can be anonymized, properly protected from snoopy lawyers, and curated. That's the only way it's going to end up in a database. Because otherwise, if it's discoverable, it's not going to happen. If it ends up on the projector in courtroom 17, no one's going to allow it to be used, in my view. So, but the opposite problem is happening in that realm right now. I mean, Getty Images just sued the guys that make Stable Diffusion because they engorged in 12 million of Getty's copyrighted images, and they're deriving work from that. It's not their intellectual property. So, because right now these things just go out, hoover up everything they can find on the internet, good, bad, or indifferent. And then you end up with, racist, misogynistic, terrible stuff. So, other questions? It's getting late.
Thanks for the talk, it's really interesting. If we take the kind of the point you made about counterfactual reasoning and work backwards.
Well, it's Judah Pearl's point, but yeah.
Yeah, we work backwards and say that we think about AI more as a tool, maybe an evolution as your diagram suggested from Rhino or CAD. With tools like Rhino or CAD, we think of them sort of as neutral tools that we can make whatever within, but in fact they're not really neutral. And we know this from Design Studio, the Boolean command for creating graph design, things like this, where they bias certain actions. I wonder how the idea of pooling data and training data is distinct from the actual bias of the tool itself.
It's not, and I think it's a real problem. Nancy certainly said this a million times, but I ran the AutoCAD team for 2 years, which scared the shit out of me, by the way, because I was an architect running the AutoCAD team. And I used to say to those guys, I can drive around an American city and I can tell you, that's an AutoCAD 10 building, that's an AutoCAD 12 building, that's an AutoCAD 14 building, and that's bad. That's bad, that's not how it's supposed to work. But look, we made splines, suddenly everything's curved. Now a lot of bad buildings look like Revit models. At least you know who to blame, right? Yeah. You can blame our software engineers for what they did. With this stuff, where you cannot understand where whatever it is came from, you can't curate it, you can't frame it ethically, you don't know the source. I decided to do an experiment today. These are 2 sets of Stable Diffusion images that I generated. The top one is an architect, an architect working in an office with collaborators using a computer. There's a lot of white people in those images, and apparently it's important for architects to wear hard hats in the office. And then the other thing I said was that I said, draw me a floor plan of an exit stair. I made my cue much simpler. Does anybody see any plans there? The thing on the right, I think, is a plan.
Looks like a Piranesi prison, though.
It does. So, and where that data came from, nobody knows. All right, go ahead.
But, okay, so to me, why make it easier for the data to this doesn't seem to approach replacing architects.
No, not yet.
And not yet. And even if we do get there, why are we making it easier for certain processes of universalization that will definitely not be universal in terms of access to the data, and then all the sort of real world implications of sustaining and maintaining a physical data center that has a real geophysical location and reality that will be accessed by certain people or certain nations. And if you're saying that a lot of the stuff that related to related to code and like just like meeting basic safety standards will be the parts that are easily automated. In this rubric, wouldn't, from what I understand, like where maybe some of the highfalutin reasons for being an architect that can slip in through these negotiations and slip into the design, but like if we data bank everything, wouldn't it no longer give space to like these kind of like messy fuck up spaces for business people, but like actually beautiful for architects? Like I guess why move towards this like centralization when I think some of the biggest space for agency for architects now is like the mess and like kind of the geographical like specific like our priorities designing in America is not the same as in.
I'm not arguing against the mess. I embrace the mess. I'd like you to have more time to make a mess.
Right.
I think if you spend less time detailing toilet partitions and trying to figure out how flashing detail worked and arguing over a contract with a contractor about how much something was going to cost, or hiring 73 consultants to model your carbon, you could spend more time making this. And I take your point about the data center infrastructure, but that ship has already sailed, right? You are personally using those data centers on your phone every day.
I'm not worried right now that my like really crap model in like Revit is going to like start like gathering, like generating like grandchildren of like horrible design somewhere.
Right, no, I don't think that's.
So like, but the thing is, if we had this central thing, like it's possible, right? So like.
Well, I don't think the presence of the data prevents bad architects from using sophisticated tools to do shitty buildings. You're never going to stop that, right? The question is, we are going to be living in a world where data is translated into results in some form. How much control do we want to have over how that works and what it means? And I think you should be given as much opportunity as possible to make as big a mess as possible, which gives you as much time as possible to convince your client to build the mess. But when you're ready to actually build that mess, it has a lot of implications that you could use a lot of help figuring out. I'm really not interested in design generation with this stuff. I personally think that's playing with fire. I think we could find ourselves in serious trouble. And that's way worse than a bad Revit model or a crappy AutoCAD 14.
Yeah.
Thanks. I really enjoyed the talk, and also reading the book. I have to say it was really nice the way also the presentation you begin autobiographically. So I think it really sets up nicely your stakes in it. I couldn't help but think in seeing this and the kind of just way that people's faces get all messed up as well, that it's a little bit like the way in which there's some languages for Google Books that when you try to translate them really suck, and others that do really well. And the reason that some say like Urdu is very difficult to get good translations of, Hindi's a little less, and then Italian's super easy, is because there's been so many translations between English and Italian, a little less between English and Hindi, and then a lot less with Urdu. So there's also the unbelievable amounts of human labor that go into making that. So while we talk, it's a very low-hanging fruit point, but I think the question for me is in the way that you're talking about the medical profession, which on the one hand does protect these things, but there are startups of trying to make it smoother when you work between hospitals, because it is kind of difficult, right? You have to do the same forms over and over.
Oh, yeah, I'm not saying they perfected it, but for the important stuff, the stuff that'll kill you.
Sure, I agree for the most part, but I wonder if in the way that Google has stepped in to do Google Books in a way to do a lot of this work, if you have to kind of hallucinate on who's going to be in the future doing this, I don't think it's going to be I don't imagine it be the UN. And the way that you said about 33 different ways to draw doors, what institution do you think is actually going to come in to want to codify and do all of that backbreaking work
Well,
make
but
that accessible.
I'll tell you what I've gotten interested in. You can tell, I just go. There's no agenda here. I give up the computer graphics course and I go to the natural language lab. There's no rhyme or reason to this. But the stuff I'm really interested in right now is 3 things happening in the UK where they are super organized and they think about these problems in a structured way. One is the Modern Slavery Act, which is a legal requirement that they begin understanding and disclosing their supply chains. The second is all their climate change stuff, which in their case drove the entire government technology standard for the building industry in the UK. But the one I'm really interested in is this brand new thing called the Building Safety Act. After Grenfell, they passed a lot of legislation that said that buildings have to have data collections that they call the golden thread. They don't define it's beautiful. They don't define the golden thread. They just basically say, you better document everything about this building. So if something terrible happens, we can find out why and whose fault it is. So there's suddenly these, and climate change and modern slavery are the same problem. They're about creating coherent, integrated representations of the building phenomenon. And I'd like to think that that stuff is going to push us in the direction where these kinds of structures might be created. Like this modern slavery thing that we're working on is this huge, intractable problem with really distended supply chains and political problems and graft and corruption, enslaved children. It looks really terrible. But like there was an article in the Times this week about painting things in the supply chain with DNA and then using DNA to trace it. There are these little glimmers that we might be able to figure this out. And I think we might be able to figure this out. But there's gonna have to be a specific lens that is catalyzed by an external force. Because when the architecture profession tries to do something internally generated, you get the American Institute of Architects, which is a serious problem, right? Just can't do anything, cannot do anything. So there has to be some outside force, right? I mean, the outside force of sustainability got a bunch of architects interested in sustainability and they couldn't do anything in the AIA, so they formed the US Green Building Council. So maybe sociologically that's what's happening, but it has to be an outside thing. I don't think we can self-invent it. But better hurry up, because rendered my book half irrelevant in 6 months.
I think it's really an interesting point you bring up on the Modern Slavery Act in the UK, though, that it's punitive in nature. This golden thread, we don't need to identify the golden thread, but we are going to document data in case something goes wrong.
Right, well,
the punitive nature of it.
I know, but at least it's an existential threat that got them to do it.
For sure.
Because that Grenfell thing, the architects in the room, you should download that Grenfell report and read it. It is absolutely heartbreaking what happened in that situation. It was a failure, it was a systemic failure of epic proportions. And 84 people were killed, and there are 44 more buildings in London exactly like it, waiting to burn down right now. It was a terrible, terrible failure. And we have no one but ourselves to blame for that. In the building industry writ large. That's a happy thought to end on. Should we wrap it up and say goodbye?
Yes, please.
Okay, guys, thank you very much.